Okay, happy Thursday. How's everyone doing? We were playing around with these AI tools in Google Photos. You saw the original photo. This is the AI version. How are you all doing? Does that look like me? Does it look like Maxine? Yeah, good question. Lots of weird decisions on AI's part. Y'all doing okay? Staying in the mix of things? Staying alive, that's good. Yeah, I know for a lot of you this is like midterm season. If you're in that boat, you are A-okay. You know how to make it through. Put in the work, do good things. We have a bit of housekeeping here at the beginning. Your mini exam 1 is back to you, so take a look at that after class. I was very pleased. If you weren't pleased with how things went, come talk to me afterwards. I'd love to talk after class or in office hours, or we could chat about it over email. I want you to feel good about, first off, the way your mini exam was graded. It should always be clear to you, like how the rubric was applied. So make sure you're comfortable with that. Also, if you want more material or you didn't feel good about how the first one went and you want more preparation going into the next one, don't hesitate to reach out about that. I'm always here. I want to make this class as accessible as possible. So if there's anything else you need or any extra preparation, I love it when people come to me about those things. Let's see, and then homework 2.2 and 2.3 are due this week, so they're due on Friday. As always, if you need an extension on those things, just send me an email. You don't have to hear back from me to get the extension, you just have to let me know before the due date. Okay, any questions? You all feeling good? It's always nice to see you. We have a good one today. This is, we're going to talk about what we call data filtering, which is one of the big topics in data operations. It's one of the things you'll probably spend some time with your final project. I was talking to someone in my office yesterday about one of the students in the class is kind of already started on a final project, and we were talking about some things to do with data filtering around that project. So this is one of the bigger topics in data operations. But if you remember where we left off last time, we had, at the very, very end, we talked about this scatter plot. So you'll remember we had the linear scale. We were talking about data transformations. And we were realizing this figure isn't, with a linear scale like this, this figure isn't that informative. It's pretty difficult to see whether there are trends, whether there's a relationship between the two variables. And so what we did was we transformed both of the axes with a log scale. But then we asked a sub-question. This was a bunch of coffee exporting countries. But our sub-question was whether there was a relationship between these two variables among countries just in the Americas. And I showed you this figure at the end, which was, oh, did I? Yes, I did. I showed you this figure at the very end, which was just selecting the countries within this data set that are in the Americas. We have lots of countries. Many are not in the Americas. But we wanted to be able to isolate just the countries that were in the Americas. This is where we left off last time, and I told you we're going to spend a class period talking about how to do this thing, where we take a bunch of data and we just select some of the data based on some condition. So in this case, it was that they were on the North or South American continent. Okay, so that's what we're doing today. Any questions before we get in? Great. Nice to see you. So, let's get rid of this weird and distracting picture. We're going to spend this class period going through this kind of example. Imagine yourself as the manager of a new coffee location. It's like a Starbucks branch, and you're thinking about how to set hours for the branch. And it turns out the location you're starting is in upstate New York. Anyone from New York? Okay, from New York City or like upstate? Anyone from upstate? Nice. Okay. So yeah, imagine this is in your backyard. Let's say this is like close to the border to Canada. I'm actually going to Toronto this weekend. So yeah, thinking about Canada. What a great city. And it turns out it's like 5 hours away from here. It's almost as close as DC. Basically, is as close as DC. Not too far. And so you're thinking about, decisions about this location. The first one you might think about is when to set opening hours. So when do you open and how long do you stay open? We've used the Starbucks location hours data set a couple of times already. We're going to use it in a slightly different way today. We're going to try to set opening and closing hours for our new Starbucks location. And we're going to use existing Starbucks locations as a reference. So we're going to look at others and try to use that information to make a decision about when we open and how long we stay open. Okay, and as always, I'm going to ask you a bunch of questions. So we're going to break this kind of into two parts. The first part is going to be when should we open the Starbucks branch? Like what time in the morning should we open? And like we generally know morning is the best time. Let's say I give you this information. We used some of this last time when we were doing data transformations. Anyone getting tired of talking about Starbucks and coffee? Okay, love the honesty. Yeah, we'll switch topics. We're gonna start hitting part 3. We're gonna start actually talking about economics research papers. But these are, I love coffee. How many of you have been to Starbucks this morning? 2, all right. Waning popularity. Yeah, I wasn't either. Starbucks is going out of style. Okay, so this is a data set. If you were thinking about how to summarize this data set for our question, maybe just as a warm-up question, I want you to tell someone next to you where you might start. Like, we're thinking about when to open, how might you use this data set to inform that decision, and what might you do with the data set. We'll take like a minute here. Silence is not the right volume for this room. Row 1? Oh, you mean this? Row. Oh yeah. So it's like a rounding issue. So yeah, we'll take it as correct. Yeah, but that's a rounding issue. So it actually opens at 7:30, and then we're rounding up and rounding down. Yeah, good catch. Okay, someone want to tell me what you, like, you're approaching this question, you have this data set, where do you start? Yeah.
I just looked at open.
Okay. And
I saw there's a lot of eights.
okay.
So I thought maybe that'd be a good time to open.
So lots of eights. So maybe just given this this like header for the data set, maybe 8 is the place to start. What else did we conclude? Yeah, Darren.
I don't think this is a good graph to determine what the time would be. I think
Okay.
because we don't have like when people are moving in most frequently. I think this only just talks about when they open and close and statistics are like now.
Okay, so maybe simply looking at when other Starbucks locations are opening doesn't give us a good indication of like demand throughout the day. Yeah. So like transactions by time. Maybe like everyone's coming exactly at 8 because they actually want coffee at or before 8 o'clock. Yeah. So maybe we would want something else. Yeah. But if you had this data set, what else might you do? Yeah.
I was going to build off what you said because like I was thinking about it like a different aspect, more
Okay.
like a financial, not one aspect. And thinking like if you start earlier, you have a greater chance to like undercut the customers that another Starbucks can get.
Okay.
If you were an alternative offer. So if you open up an hour earlier, you have that entire hour to watch like a golden hour for yourself.
Yeah. Yeah. Nice. Remind me of your name. Nathan.
And
Anthony. Yeah, so Anthony's saying maybe we should think strategically if we're making business decisions. What if we open just slightly before our competition so the morning rush comes to us instead of someone else? And yeah, that we might be thinking strategically in that way. Yeah, what else? So these are all really good insights. What we're going to go off of next is when we're looking at this data set, these managers at all of these other locations, and this is just the top 5, the header for the top 5. Maybe everyone else is also thinking strategically. So choosing an open hour that would like it's costly to open earlier, so there's a cost to it. Maybe there's a benefit by bringing in customers from other locations. So what we're going to say for now, at least, is others are operating. They've been operating for a while, at least. So we know that they're doing something well. So we're going to use other coffee shops as a reference group. And we're going to try to make our decision about when to open based on the information that's given in the data set. But I think this is an interesting observation that we should be thinking strategically with our data when making these decisions. Maybe someone else is doing something slightly wrong. But I think what we're going to do is actually use the open hour in our data set and try to look at what others are doing, and then just go off of what other Starbucks locations are doing. Did anyone decide to use a histogram? So, and maybe I didn't say that this is just the top 5 in the data set, but if I'm looking at this, I think it's pretty unclear what we should do. But I do know that we have a column that represents when other Starbucks locations are opening. And so I'm just going to use a histogram and plot out the hour of open for all the Starbucks locations in our data. And I think this is a little bit easier to understand, as is often the case. We want to use a figure in general. I think figures are easy to read. And I think this gives us more information than just looking at the data set directly. If you want to look at the full data set, which we're going to get to in our exercise, you can scroll on over and take a look here. This is the data set we're actually working with. So given this information, I want you to think like a manager for a second and tell someone next to you when you might try to set the open hour for your new Starbucks location. We'll take like 30 seconds here. Just use this information. There isn't necessarily a correct answer, but maybe try to think about when you might set an open hour. And what else you might want to know.
Yeah, because if you say six, you already have a lot of shops opening up at that time, so you're gonna get less people. So I think something important to know is what times, a good thing I should calculate potentially is a sort of ratio. So say if there was a certain time where there was a lot more people compared to how many shops open at that time, you want to open at that time. But say if not a lot of people go and a lot of shops that open at that time, you don't be worthwhile. So say if at 4, a lot of people would go and their shops open, then you want to meet them. You want to, because the demand is there.
All right. What are the times you're setting for your Starbucks location opening times? That was a weird sentence. When are your shops opening? Yeah. Okay, so 5 and 6, it seems like that's probably the most common. So from this figure, we know the most common is actually 5 a.m. or sometime in the 5 o'clock hour. I'm grouping 5 a.m. and 5:30 into one bin. And then 6 is also a pretty common opening time. 7 o'clock is pretty common as well, but everything else seems to be a little less common. So the top 5 we saw from Hong Kong was a little bit later, seems to be less common than the middle points in our data. Anyone else choose something different? Yeah, I think this figure gives us a pretty good indication about when the most common opening times are. If you're thinking about your Starbucks location in upstate New York, right on the border with Canada, is this enough information for you, or do you want something else? Did anyone see limitations with this figure? Yeah.
It doesn't tell you how many people are going at the data now.
So again, yeah, so Luke's bringing this up again. We also, in addition to just the opening times, we might want to know like frequency of transactions during these shifts. And you'll remember we talked about, I think it was like part 1.1 or 1.2, we talked about creating histograms of transactions by coffee shop, which is a great approach to take. Here we don't have that data. What else might be some of the limitations of this data for our question specifically? Yeah.
We don't know the opening time for upstate, like location or something.
Yeah, very nice. Remind me of your name. I'm sorry. Jake. Jay. So Jay's saying, look, upstate New York actually could be very different than Hong Kong, right? So like opening times in Hong Kong we saw were like maybe 8 o'clock in the morning, where it could just be different in upstate New York. And so what if we specifically look at the coffee shop locations that are similar to the one we're trying to open? So what if we do that? What's maybe a place we could start? Here we have country code, we have open time, we have close time, and duration hour. What might we do with our data to make it more informative for us, for our question? Darren.
We can filter country code by New York.
Yeah, so we could filter country code. It turns out New York is not in our country code. We need something else, but we do have US, so maybe this will do for now. So let's filter for just the coffee shop locations that are in the US. And let's check whether that's different than opening times for every Starbucks location globally. How many of you think they'll be different? And how many of you think they'll be the same? Okay, and then everyone else abstains. Maybe I've put you all to sleep for the entire semester with data cleaning. I hope not. I think they're going to be different. I've seen the slides, so I should know. So let's just filter for Starbucks in the US. This is what we call a filter, right? We're selecting the data according to a column, and then filtering out everything else. So we're just selecting from a column to give us just the Starbucks locations that satisfy some condition. We're going to do this in Excel in a second, and Python. Okay, so you're looking at this. We had this figure before, and now we have this one. Does this look different? Yeah, a bunch of yeses. This is different. So if you're looking at this figure, I think this one's more informative. This one tells us even more strongly that we should be opening pretty early, like 5 a.m. Any questions here? All right. So this is what we called a categorical filter. We're filtering by the category of being in the U.S. But it turns out, I mean, I'm thinking about Canada this weekend. We're on the border of upstate New York and Canada. So maybe we also want to include Canada as a filter. So we look at coffee shops that are in either the US or in Canada. So we can combine filters in this way to not just look at one condition, but also the possibility of a couple. So we're going to look for locations that are in either one, either the US or in Canada. You all are familiar with Venn diagrams like this? I love thinking about Venn diagrams, just the logic of these things. We say we use the and condition to tell us that we're in both conditions at the same time. So it's the overlap of the two circles. And then we use or to denote being in either one or in both. This is actually going to come into play a little bit later. We're going to use these ideas of overlapping sets and or conditions when we combine filters. So if we're filtering for US or Canada, we want to select all of the Starbucks locations that are in either one. And so in this case, that's an or operation. If it's in the US, we want it to be selected. Or if it's in Canada, we want it to be selected. And it turns out there's not a lot of difference between opening times in the US or in Canada. Okay. Any questions here? Can I give you a comprehension check? What if we filtered for shops in the US and Canada? What would that figure look like? We'll take about a minute here. I want you to tell someone next to you what the figure I'm about to flash on the screen will look like. And we'll take about a minute.
Because before, time space, we talk about the coast. North and South West Streets.
Since it should be similar without like circles.
It's okay, so we lost our seven.
Okay, someone tell me what this figure will look like. Someone want to describe this? Yeah, Alexis.
It would just be a combination of the two, so all the times from the US and Canada on one Instagram.
Okay, so Alexis is proposing that it would look very similar, identical to this figure. Anyone disagree? Yeah. Okay, so this figure is showing us all of the locations that are either in the US or in Canada. But what we're asking for here is the intersection of these two sets. We're saying we need it to be both in the US and in Canada. We look row by row and we check whether it's contained in both sets. It needs to be a part of US and it needs to be a part of Canada. So in this case, Alexis gets 10 lecture points. Congratulations. It's actually an entirely empty figure. So it looks like this. Is this informative? No, it's not. This is a fun figure to make. Totally empty. Okay, any questions here? If we want either condition, we used or. We said, is it in condition A or condition B? If we want the intersection of the two, we use and. We say it must be in both. It's in Canada and it's in the US. And it turns out in our data set, we don't have any Starbucks that are on the border of the US and Canada. So we get an empty set. Next, so this is our original figure. We said these are all of the opening times for the Starbucks locations that are in the US and Canada, or Canada. And these are all of the Starbucks locations that are not in the US or Canada. And it seems like those open a little bit later. So maybe the US has like a culture of drinking coffee earlier, which is interesting on its own. Okay, any questions here? Let's dig into this data. We're actually going to do some filtering. I'm going to show you a new technique in Excel, and then we're going to do something similar in Python. So let's say maybe our first conclusion is that we should open earlier than 7 a.m. I would say that's a pretty good conclusion, and probably opening at 5. All right. So what you can do is hop on over to Starbucks exercise 2.3. You've seen this data set before. It's in a slightly different format than the times we worked with it before. So I'm going to go to our class folder, the in class. I'm going to create. Have I told you Okay, I don't even have to say the joke. Part 2.3. And then my downloads folder. I downloaded this file. I'm just going to drag it over. Rename this. I've downloaded it a couple of times. And then I'm going to open it and then save it as an Excel workbook. Okay. So very nice. We mentioned once before that we can create data tables within Excel. This is just a pile of data, but Excel gives us some extra features that can be useful sometimes. This is one of those cases where a more structured data format can actually be helpful. So we're going to create, I think we've done this once, maybe in passing. We're going to create a data table in Excel. How many of you have done this before? Yeah, nice. So what I'm going to do is, so on a Mac, if I hit Command A, it's going to select all of the data. And then from here, I'm going to hit Command T to create a data table from the selected data. So I hit Command T. On Windows, I think it's Control A and then Control T. This is just going to ask me some questions about how I want to create the table. I want there to be headers, so I'm just going to leave this checked. If I hit OK, it structures the data as a table. And what's nice here is we can perform data filtering very directly on this data. So the first thing I'm going to do is try to filter out all of the Starbucks locations that are in the US. So actually, before we do that, let's create a histogram of opening times. So I'm going to select the open column. I'm going to go to Insert, click on Histogram, and it creates the terrible looking histogram as always. So I'm going to right click, double click on the bars, go to bins, set the bin width to be 1, and that looks a little better. So I'm going to say open times for Starbucks open times. Okay. One thing we haven't talked a lot about is downloading our figures. As we start making our way towards final projects, it's good to keep track of the figures we produce. So in this case, I actually want to save this. So how many of you got a histogram here? Okay, hands are good. What I'm going to do here is just right-click, go down to Save as Picture. It's going to go to, those are my baby pictures. That's not what we want. We're going to go to the folder that we use for the class. So let's call this Starbucks open times .png. PNG is just a format for saving figures or pictures. So I'm just going to hit save, and if we go back to the folder, you can see that it's saved here. So this is nice. Most of you are doing this for the homework, but I think it's worth just mentioning this. You don't have to screenshot your computer to get a figure. Okay. So the next thing we want to do is actually filter out a lot of this data. We only want to select the countries, the Starbucks locations that are in the US. So we have this handy country code column, and this is where we're going to actually do the filtering. If you go up here to the upper corner and you click on this, you'll see a bunch of options. We have this filter option, which is really nice, which lets us actually just do some filtering directly. And what I want to do is go down here to choose one. And this gives us some options for the logical check that we're going to perform. Here, I just want to make sure that the entry in the country code column is equal to the US. So I just want it to be a US country code. If you're on a Windows computer, are you seeing this? Does it look the same? Anyone running into a problem here? Sabi? If you're running into problems, maybe just find someone next to you and try to debug. someone else around you has figured this out. So maybe be helpful to anyone who's having issues. So what I'm going to do, and if you're debugging, you can keep talking, just turn the volume down a little bit. I'm going to hit equals, and then you can see some of the options here. So I'm just going to scroll down and just take a look at what's available. One of the options should be US. So the very bottom one is US. I'm just going to say is equal to US. And if I hit enter, or I just let go, it's going to filter out all of the Starbucks locations that are in the US. So I'm going to hit enter, and then I'm going to exit out of this. Okay, so what I've done here is create a terrible figure. But the filtering itself has just selected all of the Starbucks locations that are in the US. Turns out there are a lot of them. Our figure got cut off, so I'm going to maybe try to place it on the back side. So I'm going to create, because it filtered out some of the rows that were overlapping with the figure got cut off. So I'm just going to go up here and insert the histogram again. Oops. We need open, and then histogram of the open hours. So this will give us the histogram of the open hours for just the Starbucks locations in the US, which looks like this. So this is open hours US. Okay, any questions here? So we're going to take 2 minutes here. I want to show you how to do multiple filters. So filter by multiple conditions. The way we do this is once we enter the first condition, we actually have the possibility of entering a second one. What I want you to do is to select for all of the Starbucks locations that are in the US or Canada. Or and. You're going to choose. We'll take like 2 minutes here. I want you to construct the figure I constructed in the slides, looking at both the US and Canada Starbucks locations. And then we're going to create a figure that does that. Go. Yeah, so there's an option here, and you're going to have to pick which one, and or.
Sure.
All right, someone walk me through what you did. If you're still working, that's great. What did we do down here? Savi.
I personally used OR.
Okay.
So I went to the OR, put the word in.
Yep.
And then in the next section, I put in CA. And
Okay.
like click videos.
So
And
then
put
CA.
And then
Okay. Nice. Anyone do anything different here? If you used and, you can see what happens. We select no data. We're selecting for country codes that are both US and Canada, which in our format here is impossible. So we're going to select OR. And then again, we're going to construct a new figure. If you want to, I think when we're doing filtering, it actually makes more sense to insert figures on the backside on a separate sheet. It's a little bit more work. You have to select the data from the original sheet, but you can do that. So then when we do any filtering, we can actually, the fact that we're moving rows around doesn't impact the figure itself. This is one of those things about Excel that I find a little maddening. But you can play around with that. So we'd call this locations, let's see, open times US or Canada. All right. And then here we can save this again. So this is right click, go to save as picture in our folder, and then we could say Starbucks open times US Canada. And that will give us two figures actually. So we have this one, and then we have this one. All right. Any questions here? This is what we call filtering by category. So this is checking whether a logical condition is true. So looking at a categorical variable and then finding everything that matches. But this is not the only kind of filter we can do by inequality. Before we turn to filtering by category. Before we turn to filtering by inequality, I want to show you how to do this in Python. So to do this in Python, all we have to do is jump over to the notebook. I've set this up nicely for us. So we have the imports at the top. And we can just load the data set from my website. And here we can see the header for the data set. I've included the code in the slides here. So the first thing we could do is just create the histogram, which I would like to do at the very beginning. This is just to plot all of the opening times for all of the data. So we've done this in Excel. Does it feel redundant to do this twice, or does it feel helpful? Yeah, I find showing these steps in Excel and then showing how we copy them, sort of mirror them in Python. Personally, I find that helpful. So here I'm just going to create the histogram in Python in Seaborn. So this is just the open. So we're using this open column as our X variable. I've defined the bins, and we're using the hours as the data set. So nice. But this is not everything we want. Actually, I might put a title here. So plt.title. So this could be open times or Starbucks open times. But this is not everything we want. And if you wanted to save this, you just right-click Save Image As, and then you could navigate to your folder. So call this Starbucks python.png, and that will show up in the folder here. So we can see that here. We'll do that a couple more times just so we get familiar with it. But we want to do some filtering. So I've included some code in the slides here. When we do filtering in Python, instead of like clicking on a data table like we did in Excel, here the tricky thing with Python, as always, is that we have to remember the steps. Like we don't have a sort of click interface. But the nice thing about Python, the reason we use it in all of science, essentially, or code of some kind, is that we can reproduce it very easily. It's very easy to know what the steps are that we performed, and then to be able to do them again. So as we go through, like as I write out the notes for these exercises in Excel, I have to actually document each one of the steps. But when we do it in Python, we just have it all written down sort of automatically, which is part of why it's powerful. These are just some of the logical conditions we'll talk through. Here, we're just going to use equals for the first one. So we're just going to say we want the shop to be in a certain set. So in this case, when we're looking at country code, we want it to be equal to US. This is, I think, a mistake. The code is not country_code. It looks slightly different. So it's actually going to be, oh, look at that. No, it is right. So country code. So you have access to the slides here. Let me just show you what this does. This is checking each row whether it's in the US or not, whether the country code is equal to US. And then it's just going to give us a list of true and false. So if we copy this over and paste this in, this is just going to be a list of true and false. So this here, US codes, this is just a list of true and false. So you can see when it's false, it's telling us that that coffee shop is not in the US, that the country code is not equal to US. And when it's true, it's telling us that the country code is equal to US. We use this doubles equals sign to indicate a logical check. So this is asking whether it's equal or not. When we use the single equals sign, that's telling us that we want to assign US codes a bunch of values. So we're just defining this thing to be this thing. So it's a definition. Okay, so this is nice. What we actually want, though, is to select only the country codes that are true. So the next line here is just, we're going to, in brackets, put this list of true and false into the data set. So we're going to say, I only want the things that are true. So I'm going to select this bit. So I'm going to look at US hours, which is equal to just all of the data in the original data set hours. But I'm going to select only the rows where US codes is true. So it's sort of two steps to the logic here. I'm going to show you a simpler way to do this, which is how everyone does it. But I think it's valuable seeing these two steps written out. If we run this, we can see our new US hours. So we've defined a new data set called US hours, which is the filtered data. This is something Excel cannot do, and is actually one of the powerful things with Python, is we've created a new data set based on the filtered data. So this US hours data set is all of the data that's been filtered. This allows us to do some extra things that's pretty challenging in Excel, actually. If I print out this data set, just the US hours, you can see this data set only contains Starbucks locations that are in the US. Okay. Any questions here? This is the complicated way of doing it. I want to break it out this way to show you what's going on in Python. But the way we write a filter is actually a little bit simpler. Instead of writing it in these 2 lines, we actually just usually write it in 1 line. We say, inside the brackets, we're going to perform a logical check. This is the filter. And then we put it in brackets for the data set that we want to actually filter. So we're selecting every row where the inside returns true. So row by row, we just go through and we select all of the data where the logical condition returns true. So I'm going to copy this. This is the code I use. And I'm just going to place it in here. You can do it the other way if you like. Some people do, but it's more common to see it written this way. This just selects all of the rows where we return true inside the brackets, where the data in country code, the column country code, is equal to US. So if I run this, I get the filtered data set. Okay, so let's take 30 seconds here. I want you to create a figure, a histogram of this filtered data set, and then save it to your local folder. And then tell your neighbor that you were successfully able to do it. Take about a minute. Savi.
So I heard, like, doing the US hours, I'm getting something it's also
All right, so I'm just going to create a histogram here. How many of you were able to get this histogram? Okay, if you didn't, maybe check with someone next to you. Someone next to you did get it, so be helpful to the people around you. A general rule for life, I think. This is just one line of code to create the histogram. It's really the same as we've always done. We're just replacing hours with US hours. We're going to do one more step here, and then we're going to turn to our last topic in the last few minutes of class. We can perform multiple logical checks using either the AND or the OR operator. Here, I'm filtering for coffee shops that are in the US, and then I'm going to use an OR operator to return true if one of these two things is true. So if I copy this, I have two logical checks. So the first one is whether the country code is equal to the US. So let me just run this separately, which gives me all of the country codes that are in the US. But I could also run this as Canada. So this is going to give me all of the locations that are in Canada. Both of these are lists of true and false. But if I give it both the US and Canada using an OR, so I say I want to select all of the countries, all of the locations that are either in the US or in Canada. It's going to give me true anytime either one of them is true. If I run this, I can see all of the US locations at the bottom of the list return true, even though we're also checking for Canada. So we know that this is the OR operation because it's returning true for both the US and Canada locations. The other operation we could use is AND, but this is going to return false for everything because, as we've seen before, if we filter for coffee shops that are in the US and Canada, then we don't have any locations that are on the border, so we get an entire empty list. If I run this, this is selecting the data in hours where the locations are either in Canada or the US. So if I run this, we can get the Canada and US locations, and you can see that here. If I were to flip this from an OR to an AND, you all know what this would look like. Just be empty. So this is the empty data set. We just see the data set with no entries. But that's not what we want. We want the OR. Okay, any questions here? So you can plot this if you like. Here's the code in the slides. All we're doing is just plotting US and Canada data set across the open hours. But for the sake of time, we're just going to skip this. You can work on this on your own. I also give you a little bit more. Actually, I don't give you more. We'll come to that at the end. Any questions here? Could I get a raise of hands? How many of you prefer filtering in Excel? And how many of you prefer filtering in Python? Okay, about 50-50. We're like cruising right down the middle. Love that. So it's a good thing we're covering both. If you like filtering in Excel, some people do it that way. I strongly prefer doing it in a way that's easily reproducible. But I do think some of the logic for how we write the filter in Python can be a little bit unintuitive. So if that's tripping you up a little bit, you're in very good company. Writing out the logical filter, getting the true and false for each one of the logical conditions, all of that is, I think, just not super straightforward. So you're in good company there. Okay, so at the beginning of class, we talked about that we have two questions. The first one is, when should we open? And the second is, how long should we stay open? We answered the first question, which is, let's open before 7 a.m. But in the last few minutes here, we're just going to cover how we answer how long we should stay open now that we know when we should open. Okay, so this is the data set. We spent some time looking at this. Darren's observed that this is a mistake, this 14. That doesn't follow. I think that's a rounding error. But if you're looking at this, what's a good place to start, just as a general first step for how we should think about how long to stay open? Maybe tell your neighbor. We'll take about 30 seconds here. What should we do and where should we start?
Yeah.
Okay, someone help me out here. Where do we start and what do we do? Or maybe what's one thing we could start with? Jay.
Create an histogram of the variation.
Nice. So let's start by creating a histogram of duration hour, which could look like this. In fact, it does look like this. This is how long Starbucks location hours, how long Starbucks stay open globally. Someone tell me, how long should we stay open? We open before 7. How long should we stay open? Yeah.
14 or 15 hours.
Yeah, 14 or 15 is roughly the mode. Yeah, maybe 16. It changes, right?
Alex.
Oh my goodness.
I think Jason's.
I'm sorry.
You're good.
Alex.
Yes.
So Alex is recommending we start. We open for. We open before 7 a.m. and then we stay open for what was it, like 14, 15, maybe 16 hours. Could even be 13. We've got kind of a range here. What else might we want to know? Is this enough? Luke is saying no. No is an easy answer. I'm curious what else we might need to know. Yeah.
I'd be thinking more like population size seems usually stay for that long.
Okay, maybe cities stay open longer. Like New York never sleeps, right?
Yeah, like I'm from New York, so like I get it. Like some of my friends, like they skipped college or they went to do college.
Yeah.
So, like they work out in the city.
Yeah.
So, like they're up in the morning, so when the coffee shop's open at 5, they go there until like the Starbucks is on.
Yeah.
So they get foot traffic from there, and then some places don't. Like some places are open from 5 to like 8. So like 5 a.m. to 8 p.m.
Yeah.
open.
So again, we have, like, this looks at every coffee shop in the world. What we actually want is a subset. So we want to look at some maybe geographic filtering. What else might we do here? So remember, we don't have like population size, but we do have country code, so we can filter again like we did before for US and Canada. So we could look at all of the durations for Starbucks that are in the US and Canada, how long they stay open. But there's another thing we could do to filter. Yeah. So we know something about our Starbucks location. We've already decided that we're going to start before 7 a.m. Let's filter for Starbucks locations, and we're gonna do the location filter in a second, but we're gonna filter for locations that open early. We know we're an early opening Starbucks, so let's filter for how long those Starbucks stay open. And if you think about it, this actually might be an important filter for us. if you open later in the day, there's just fewer hours left. So you may actually be open less time if you open late. But because we're opening early, it could just be that early open Starbucks locations actually stay open longer. Okay, so let's do that. So far, we've filtered on category, but we can also filter on inequality. So these are just some standard mathematical symbols. I think all of you have some familiarity with these, but we can use all of these kinds of filters, all of these symbols as filters. So the first thing we're going to do is look at Starbucks locations that open before 7 a.m. We're going to do this in Excel and in Python in a second. Turns out none of the coffee shops that we have as the header in Hong Kong open before 7 a.m. What we're going to do is filter our open column for 7 a.m. So the number has to be below 7. So the figure, the way this looks, we go from all of our coffee shops to all of the ones that open before 7 a.m. So someone tell me what happened here. Just quickly, what's the conclusion as we go from all of them to the early open Starbucks? Is the question too easy? Maybe tell someone what the conclusion is. You're opening early. So someone describe what we've seen here. We've done the filtering. What do we see? Yeah.
The earlier you open, the longer you stay open.
Yeah, so early coffee shops tend to stay open longer. And if we were choosing a recommendation here, maybe we actually go with our 15 hours. So that it could still be that 15 hours is the mode, where before it was maybe slightly earlier. Could have been 14. Okay, so I think this is one of the important ideas with filtering. When we're making comparisons, we actually want to filter for the correct reference group. We look at the reference group that makes the best comparison, and we can do this by filtering. Here, we can filter for inequality, but we can also filter not just for inequality, but also for category. So we can do both categorical and inequality filters at the same time. So here we're just looking at coffee shops that open in our reference group earlier than 7 a.m. Here I'm just showing coffee shops that open later. They tend to stay open less time, as we'd expect. But we can also filter for location. So what I've done here is just plot out the coffee shops that are opening early and are in the US and Canada. We know that we're right on the border of the US and Canada, and we open early. So our reference group is actually sort of the combination of all of these things. It's actually three categories. We want it to be opening early, and we want it to be in either the US or Canada. And that's the distribution for duration that makes the most sense for us. So in this case, it turns out we should stay open about 15 hours. All right. Any questions here? Nice. This is just a figure. We've talked about turning histograms into line graphs. I have some code for how to do this in Python at the end of the slides. It's a little bit more tricky, so we're not going to spend a lot of time on it. What I do want to do is talk through how to do these multiple inequality and categorical filters in Python and Excel. I think we have just enough time to cover it. Maybe not. We'll see. So these are maybe some of the recommendations we've collected from our filtering. So let's hop back over to our Excel spreadsheet. So here we've filtered on country code. So we've already filtered for the data that's in the US and Canada. For the sake of time, I think what we'll do is we'll just apply the second filter. So we've already filtered for the locations that are in the right locations. If you were thinking about doing a filter on opening hour, where might you start? Is the question too easy? Am I asking you silly questions? No. Alexa says no. Let's take. Is that an answer?
You just click like the filter button on opening times.
So just click on the filter button on opening times. This applies a second filter. So in addition to the original filter, we can filter open times. So all I'm going to do here is go to choose one. So before we had equals or does not equal, but we also have inequality filters. So here I want to make sure that all of the open times are less than 7. We're opening before 7 a.m. So we want to look at only the locations that are opening before 7 a.m. So I'm going to click on less than and click 7. And once we do the filtering, we get locations that are in Canada, or if we scroll down to the bottom, we can see locations that are in the US. And we also see that they're all opening before 7 a.m. And if we go over to our figure here, you can see the distribution of open times. But we actually want the distribution of duration hours. So I'm going to create a second figure, insert, go to histogram. I haven't selected any data yet, so I'm going to go to select data up here, and then click on this little button, and then select my data, which is duration hour. I hit enter, I hit OK, and that gives us our duration hour figure. I'm going to double click on the bin, set the bin width equal to 1, and this gives us the duration hours. Duration. This is early, and then this is, we want it to be both opening early, and so it must be in the open early category, and US or Canada. And if we were trying to be logically, like write this out with great syntax, we would put a bracket around the second condition. But what we're doing here is selecting for all of the locations that are in US or Canada, but then also open early. And this gives us this distribution. Okay, any questions here? Okay, very nice. So take a look at the rest of the slides here. This is some of the syntax for how to do this in Python. It's very similar to the filtering we did with categories, except we're going to filter by inequality. I have all the code listed out in the slides, so take a look at that. This will be helpful with your homework. Homework 2.3 is on filtering, and that's due on Friday, unless you email me for an extension, which I automatically grant. Go have a nice weekend. I'll see you all on Tuesday.